Welcome to lesson 64. We are going to begin looking at the derivatives of trig, and you should have your formula booklet handy, or at least know what kind of formulas can be found in your formula booklet when you do your homework or when you prepare for your IB exam. Last year, we started looking at the many different rules for us to take derivatives of certain functions, mostly polynomial functions. Now we're going to learn the different derivatives for trig functions. Taking a look at the chart here, when the function is sine x, its derivative is cosine x. Cos x, derivative is negative sine x. Tangent x, derivative is the square of secant x. In IB, they write cosecant as C-O-S-E-C as opposed to CSC that you're familiar with. The chart on the right shows f of x is cosecant x, then the derivative is negative cosecant cotangent. So it's a product. The function is secant x, its derivative is secant tangent. Function is cotan, the derivative is negative cosecant squared. So I do see some similarities amongst these trig derivatives in a sense that I look at sine and cosine as a pair, as well as cosecant and secant. The negative signs for these derivatives are opposite, right? So you see a negative sine x for cos x, but then in the reciprocal trig ratios, the negative goes with the rule for cosecant. Tan x and cotan x is somewhat like a pair themselves because the derivative of tan x is square of secant, while the derivative of cotangent x is negative, so again the sine, of square of cosecant x. Although you're not required to memorize these rules for your IB exam, the more you're familiar with these rules, the easier it will be when you do your homework, okay? So let's get rid of these remarks for now. Let's begin to look at some examples. First, we're going to prove some of these trig derivative formulas. Let's begin with the derivative of tangent x. We are going to show that its derivative is indeed the square of secant x. I'm going to write tangent in terms of sine x over cos x as a function. As you can see, this is actually a quotient. We will differentiate sine x over cos x using the quotient rule. So take the derivative of the numerator is cosine x, multiply by the original denominator. Subtract the derivative of the denominator, which is negative sine x, times sine x, all over the square of the denominator. Okay. The numerator turns out to be cos squared x plus sine square x over cosine square x. And we know that this is 1 over cos squared, which is secant squared. B. The derivative of secant x, let's show that it is indeed secant tangent x. I'm going to take the derivative of secant x, which can now be written as 1 over cos. Okay. We can use quotient law again. 1 has a derivative of 0, so the first term is 0 minus 1 times the derivative of cosine, which is negative sine x, over the square of cos x. The top part is sine x. I will actually separate the cos square in the denominator as 1 over cosine x multiplied by sine x over cos x, which gives us secant x times tangent of x. In example 2, we will be looking at different derivative questions using trig derivatives. When you do these questions, sometimes it's good to substitute trig identities to make the original question easier to differentiate. You also need to remember all the rules that you learned last year for taking derivatives, such as product rule, quotient rule, and most importantly, chain rule. So let's begin. Example 2. Y is equal to cosine of 5x. So this is not just a simple cosine x question, because this is cosine of another function, 5x, which means that we need to remember to use chain rule. Taking dy by dx, first we start with a bigger, the outside, so to speak, function. The derivative of cosine is sine, negative, of whatever angle you have. I will write out the chain rule for now, just as a review. We will have to multiply that by the derivative of 5x, which is 5. So your final answer is negative 5 sine 5x. Question B. We have y equals to 4 sine x cos x. Some of you may say, well, right away I see 4, which is a constant I can pull out, and treat this question as sine x times cos x and use product rule to differentiate it. There's no problem with it. It's absolutely fine. But one thing that I notice is that, well, don't we know a trig identity that looks like 2 sine x cos x? What is that trig identity? It is sine 2x, correct? So now, because it's 4 times sine x cos x, we got to break up that 2 as a factor. And now we have 2 sine 2x. This way, we can avoid the use of product rule to make our solution much longer. Okay, so this is more efficient. So let's take the derivative of that. So dy by dx, I can keep 2 on the outside because it's just a multiplier. The derivative of sine is cos, positive, of 2x. Remember chain rule? We need to take the derivative of 2x again. As a result, the derivative of 2x is 2 times 2 is 4. Cosine 2x is my answer. If you're confident with taking derivatives of trig, now you can pause the video and try all the questions in the rest of the lesson first before coming to the solution. So I hope you had a chance to look over all the questions, even try them. Let's take up these questions. Number 3a. You have y equals the sine of the angle x squared. So here x squared is what's being signed, so to speak. So now when I take the derivative of y, I'm going to look at the derivative of sine function, which is cos x squared, multiplied by the derivative of x squared. This gives me 2x multiplied by cosine x squared. The difference between part A and part B of example 3 is the position of where the square is written. In part B, we are looking at y equals to cos square x. If we recall, what this means is that we have cosine x to the power of 2. This changes how we differentiate this function, because now y prime begins with using the power rule in taking derivatives. So I have 2 cos x to the power of 1, then multiply by the derivative of cosine x. All right. We know that the derivative of cos x is negative sine x. So the whole thing becomes negative 2 cos x sine x. Or you want to simplify this into negative sine 2x using identities. moving along. Example 4. Differentiate y equals the cotangent x minus 2 cosecant x. You can use the chart to help you. The derivative of cotangent x is negative cosecant square x. And then the derivative of cosecant x is negative cosecant cotangent. So now negative negative makes positive. I have 2 times cosecant x, times cotangent x. You may wish to simplify this by factoring out negative cosecant x, which means I have cosecant left in the first term, minus 2 cotangent x in the second term. 4b. Y is equal to cosine 3x multiplied by x squared plus 2x minus 1. If it helps, include brackets around cos 3x. So now you see that we're actually multiplying a cosine function by a quadratic. Y prime is the derivative of the first term or first factor. So it's going to be negative sine 3x. Derivative of 3x is 3. So that multiplied by x squared plus 2x minus 1. Plus the derivative of the second term or second factor. So 2x plus 2 times cosine 3x. You can leave it like that unsimplified. Question C. Y is equal to 1 minus secant x over tangent x. No, that looks more complicated. So I'm just going to use the most straightforward method, which is the quotient rule in this case. Take the derivative of the numerator. 1 becomes 0. Negative secant x is negative secant x tangent x. And then we have to multiply that by the tangent x in the denominator. So I'm just going to write tan square x here. Minus the derivative of the denominator. So derivative of tan x is secant square x. Multiplied by the original numerator. All over tan square x. I see common factors here. I'm going to factor out negative secant x. So I have tan square x plus secant x multiplied by 1 minus secant x. So I'm just going to expand that as well. So this is plus 1 times secant x and then minus secant square x all over tan square x. Okay. If you recall a trig identity, 1 plus tangent squared is equal to secant square x. Oops. Then we can actually substitute that for tangent square x to simplify further, because there's a bunch of secant x in this equation or in this expression. So tangent is secant squared x minus 1 plus secant x minus secant squared x all over 10x squared. Okay, so what can we get rid of? We can get rid of the secant and the secant squared, like secant squared and secant squared, which gives us secant x minus 1 times secant. Okay, so let's write this formally as secant x times 1 minus secant x. I have redistributed that negative sign into the brackets. And there we go. This example shows you how important it is to know your trig identities, because they are useful in terms of helping you to simplify your trig expressions. Lastly, let's go over example 5. You're going to find f prime of pi over 4 for f of x equals to x cotangent x. So let's begin by taking the derivative of the function using product rule. Derivative of x, 1 times cotangent x, plus x times the derivative of cotangent x, which is negative cosecant squared x. Okay. Now we can evaluate this derivative at pi over 4. We have cotangent pi over 4 minus pi over 4, which is x, times cosecant squared of pi over 4. What does that give us? Cotangent pi over 4 is 1 minus pi over 4. Now cosecant is the reciprocal of sine. So sine pi over 4 is 1 over root 2. So the reciprocal of that is root 2, but this time squared. So that's good. The final answer is 1 minus pi over 2. Or you can write it as a single rational expression, 2 minus pi over 2, which is equally okay. So let me put check marks on here. This is acceptable and that's good too. Okay.